My name is Paul Johnson. I'm a Senior Solutions Architect with Amazon Web Services, and welcome to my presentation on Redshift streaming ingestion. So one challenge we often see with data warehouses is that a lot of the data comes in batch mode, and you have to wait till the next day to see your business intelligence results. So with Redshift streaming and Redshift materialized views, we can make this a thing of the past. So let's talk about our use case. So for this example, we have a hypothetical utility in California, and they're running a contest to try to get people to try various energy saving initiatives. A few examples are shown here. Maybe wash your clothes in cold water, turn your AC up, install new insulation, and many others. So the customers that sign up for these challenges, known as quests, are awarded points, and the winners receive potential credits on their utility bill for participating. And the utility wants to monitor the contest activity in real time so they can actually make adjustments if they need to on the fly. So let's look at our architecture of the solution for this demo. So we're going to start off, we're going to use a Python random data generator to generate some completely fictitious data for the customers and for the quests that they take on. We're going to move this data into an Amazon DynamoDB table. So that's our NoSQL database offering. As you'll see in a moment, with the data we have coming in, it's ideal for DynamoDB. We're going to create a stream in DynamoDB and stream that data into Amazon Kinesis Data Streams, which is our streaming service. And then from there, we're going to push it forward directly into Amazon Redshift serverless. So there won't be any stopping in S3 and batching the data up. So all this will be end-to-end, and it'll be happening in near real time. Okay, let's take a look at the entity relationship diagram for the solution. It's very simple. We have a customer record, which includes their unique ID and a few attributes about the customer, including email, address and birthday, things like that. Typical customer record. And then we have a quest entity. So this is going to be the actual challenge or quest they want to take on. So there's a little text description of the quest, and then the valid dates beginning and ending for the quest. And then when they actually take one on, we're going to join these records together and make a customer quest mapping. So it's a combination of the quest ID and the customer ID, the date that they signed up for it, and how many points they earned. So you can see in the relational database world, this makes kind of a many-to-many relationship, which is somewhat cumbersome in a regular relational database. But as we'll see, in DynamoDB, you can actually represent all three of these entities in the same table. So that's going to be an ideal solution for our data model here. So for our next step, we'll actually go into the solution and walk through the various components. Okay, so our first component I want to show you just real briefly is our Python script. It's in Cloud9, which is our IDE environment that's built into AWS. So you can just see here, right through here, you can see the various different kind of quests that they can take on. And then this Python code is just going to generate about 100,000 records, basically at random, to get different locations and customer names. So it's as simple as that, and this is the part that we'll be running to actually provide our data. Okay, now we're going to take a look at DynamoDB. And the first thing I want to show you here is that I have a pointer set to my Kinesis data stream right here named Quest Customer CDC. And now let's go ahead and look at some of the items in the table. And let's see, we can just run something with no filter first. So this is a typical customer record. We have a unique key for the customer and then various columns of metadata about that customer. So that's what a customer record or that customer entity looks like in DynamoDB. Notice that you can also see it in JSON view, which is how the data is going to be streamed out. Next, I want to get a look at the quest metadata. So I need to add a couple of filters to show that. So we will do a filter on the primary key, contains Q #, which is for quest. And then we want to do one on the sort key where it contains metadata. Okay, and I'm going to kick that off. It's going to take about 45 seconds to find one of those. So I will stop the video for a moment and then we'll come back. Okay, we're back and we've got an example of a quest metadata entity. So we'll just drill into this and have a quick look at it. So it's pretty simple. It's got a primary key, a sort key, and then the create and end date for the quest and a quick description of the quest. So that's what the quest metadata looks like. And then finally, we want to look at one of these where the data is joined together, which is that customer quest entity we saw earlier. So I think to do that, just remove this filter and make another run. And then here is an example of one of those. So this is the Q1012 that we saw before. And it's joined with a particular customer. What that means, this customer signed up for that quest on this date and timestamp, and they got 5 points. So that's an example of that third entity. So what we've demonstrated here is that you can store all three types of entities in the same database table, which is another nice feature of DynamoDB. So our next step will be to go into Redshift and look at that later and then run the simulation. Okay, before we actually go in the Redshift console, I just want to show you the two pieces of code that we had to run in Redshift to create the materialized view and take the stream data from DynamoDB. So first piece of code is you create an external schema, give it a name, Program Analytics, from Kinesis, means from the Kinesis service. So you're actually creating a schema in Redshift. And then you create a materialized view. So I gave it a name here, and then it's set to auto refresh, and then a few columns here. The critical column to get the data is this one called payload. So we're just going to JSON parse the Kinesis data coming in from the stream. So that's really it. Just two quick DDL statements, and I have the materialized view I need to bring the data into Redshift. Okay, now I'm in Redshift. I'm in the Redshift query console. And I do want to show you one thing. This is actually that materialized view that we configured earlier. And I double clicked on it, ran a quick query. This is from a previous run. This gives you an idea what it looks like. So this is the data. It's really stream data. This is how the data looks in a Kinesis data stream. And we're just loaded it directly into Redshift. And the payload is the critical column. It has all the information. And I wouldn't be able to show you the whole thing on this view, but you can see that it's just one big long JSON string of all the data that came in from the Kinesis data stream. Okay, so we're ready to kick this off in real time right now and watch the results change as we go along. So I'm going to go ahead and initiate the script here. So it's producing records right now. And then we want to go over to our Redshift console. And I want to note that this is serverless Redshift, which is nice for situations where you have up and down loads on your cluster, a lot less to manage, and you only pay for what you use while it's actually being either loaded or queried. So that's a good feature. And then another thing in Redshift is that you can actually do some simple visualizations right here within the tool if you want to. So for this demo, that's what I'm going to do. And I've got one called Quest per minute to give me an idea of the throughput. This is one from a previous run here, but I'll go ahead and run this right now. And we should see some of the current activity coming in. And you can see it's actually coming in, and it tends to peak at 6,000 records per minute. And I can keep running it, and you'll see the graph change a little bit as we go along. So to give an idea how that looks. Okay, so it's just showing that we do have real time and a very low latency here. So that's one way to look at the data. Another way would be to look at unique customers. So I've got a graph for that as well. There's the query, and I can run this query and get an update here. So that's unique customers per minute coming in. Looks like it can max out at around 1,000. So that's where that is. And of course, you can keep running it if you want to see how it's coming along as you go. Okay, so that's near real time as well. And then I've got another, just a query saved off called the leaderboard. And this is just going to give me like a scorecard of who's got the most points, across the customer base within the last minute. So I'll run this. So you can see that customer in the last minutes, leading with 343 points. Of course, you can, if you want to look at a wider time period, you can do that too, just with a simple change. And, you get a different customer with 363 points over the last 5 minutes. So that's a leaderboard query. So again, you can see these numbers change in real time. And I'll go and get out of this. And then a couple of analytical views that you might be interested in. One is, how's it looking by city? So you notice we had address metadata coming in. This is again from a previous run. It's the top 25 cities. So when I run this, you won't see the bars change a whole lot, but just to give you an idea that it is data in motion. You can see the scaling changed, and this is just showing me the current counts coming in. So at this point, Fremont's got 1,407. If I run it again, then they've got a few more. So it's just showing you that it's continually updating as the data is coming in from the stream. So that's participants by city. Another way you might want to look at it is by age demographic. So who's interested in doing these quests by age demographic. So we'll double click there and refresh this view and see how that looks. And we'll kick it off. And so we have 30 and unders, about 14K coming in. You can see the various age brackets. So again, if I continue to run this, you can probably barely see the bars change, but these numbers are changing in real time as the streaming data continues to come in. So this just gives you an idea of the power of bringing the data from a stream and directly into Redshift. Of course, you can propagate this forward into your favorite BI tool. A good one I would recommend is Amazon QuickSight. So if you want to publish this out to a broader audience, you can do that. Okay, well, let's wrap it up and recap what we saw. The first thing we saw was high-speed data ingestion into Amazon DynamoDB, which is our NoSQL database service. We saw automatic streaming directly from DynamoDB into Amazon Redshift with no stop in S3 along the way. We saw ingestion of semi-structured data into Redshift. We saw a Redshift materialized view with near real-time latency. And then we saw some visualizations in the Redshift query editor. So to me, these are all really nice features that help to close that latency gap you sometimes see between an operational system and your data warehouse. Now, if you want to try something like this on your own, there's a workshop available, and I've put the pointer to it right here. It's a different use case, but it's essentially the same components you saw in this demonstration today if you want to get a little bit more of a handle on how it works yourself. And finally, I'd like to thank you for your time. And I have my email on here. If you have any follow-up questions, please feel free to send those along. And with that, have a good day.